Want a holiday gift your employees or clients will actually love? Send them gourmet peanuts from Hubbard Peanut Company. Hub's Peanuts is a family-owned company that's been making high-quality, delicious peanuts and sending them to every corner of the globe since 1954. Order some of Hub's plain, salted, or chocolate-covered peanuts in a special gift tin for the perfect gift for your friends, employees, clients, or even yourself. Visit hubspeanuts.com. That's HUBS peanuts.com.
Preparing for what comes next is a big part of becoming an adult. So, if your teenager says they want to join the military, they're preparing for a real challenge. Visit todaysmilitary.com because their success tomorrow begins with your support today.
This is SpaceTime Series 23, Episode 83, for broadcast on the 17th of August 2020. Coming up on SpaceTime, astronomers discover a pulsar in the process of powering up. The solar system's largest impact crater discovered on the Jovian moon Ganymede. And the International Space Station's about to get a little bit smaller with the upcoming loss and destruction of one of its modules. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have for the first time seen material spiralling into a distant neutron star and triggering a massive outburst of energy, thousands of times brighter than the Sun. The observations, reported in the monthly notices of the Royal Astronomical Society, provide the first full sequence of events across the entire electromagnetic spectrum, detailing the accretion of matter onto a neutron star, and then how that material results in an outburst phase, generating a huge explosion of X-ray energy. A neutron star is the super-dense stellar corpse of a star far more massive than our Sun. When these stars run out of hydrogen for core nuclear fusion, they begin collapsing under their own gravity. And this collapse causes a dramatic increase in the core's pressure and consequently its temperature. Eventually, pressures get high enough for the helium, which was generated out of the hydrogen fusion, to begin fusing itself into progressively heavier and heavier elements. Helium initially fuses into carbon, then neon, magnesium, oxygen, silicon, and ultimately the silicon fuses into an inert core of iron plasma, which gradually builds up in the stellar core until it reaches about 1.44 times the mass of our Sun, an important figure known as the Chandrasekhar limit. No matter how massive a star is, no star gets big enough to fuse iron into heavier elements. And so the balancing act between the outwards push of energy from nuclear fusion and the inwards pull of gravity finally reaches its end, with gravity winning. That causes the star to rapidly collapse down on itself. And because it has more than the Chandrasekhar limit of 1.44 times the mass of our Sun, there's enough force there to literally cause the protons and electrons of the atoms in the core to crush together, forming neutrons, turning the core into a neutron star. Now, at the same time as this is happening, it also triggers a massive rebound explosion called a core collapse or Type II supernova, an event so powerful it briefly releases enough energy to outshine an entire galaxy. Neutron stars are fascinating objects to study, but until now, no one's ever seen a neutron star powering up. And so to witness such an event in multiple frequencies has provided a new insight into stellar evolution. The physics behind this powering up or switching on process has eluded physicists for decades, partly because there are very few comprehensive observations of this phenomenon. To grab these historic observations required an international collaborative effort involving 5 teams of scientists and 7 telescopes, 5 on the ground and 2 in space. But it was worth the effort, with researchers catching one of these accreting neutron star systems in the actual act of entering outburst. The authors witnessed the onset of the outburst from the first sign of optical activity to the beginning of X-ray emission and all the way through to the end of the outburst. Using multiple telescopes sensitive to light at different frequencies, the teams were able to trace initial activity near a companion star on the outer edges of what became the accretion disk. They monitored the material in the accretion disk heating up over 12 days and spiraling inwards, eventually colliding with the neutron star and generating X-rays. The fact that it took 12 days for the material to swirl all the way inwards and collide with a neutron star was somewhat of a revelation, and substantially longer than had previously been thought. The study's lead author, Adele Goodwin from Monash University, says the observations provided an opportunity to study the structure of the accretion disk and determine how quickly and easily material moves towards the neutron star itself. In an accreting neutron star system, a pulsar, which is a rapidly spinning neutron star, strips material away from a companion star, forming an accretion disk of material spiraling towards the pulsar, where it releases an extraordinary amount of energy. Something like 10 years worth of the sun's total energy output over a period of just a few short weeks. This is so energetic that the majority of the radiation is released in the highest energy portions of the electromagnetic spectrum, in the X-rays. Some accreting neutron stars aren't always active, and so can spend years in a quiet state known as quiescence, where they emit barely any light at all, accreting at a very, very low rate. But then they can suddenly go into outburst, becoming extremely bright in X-rays for around a month. The pulsar Goodwin and colleagues were observing was SAX J1808.4 minus 3658, located around 11,000 light-years away in the constellation Sagittarius and spinning at around 400 times per second. What Goodwin and colleagues saw was totally unexpected. While the neutron star orbits its companion every 2 hours, the X-rays appeared 12 days after visible light increased, which was remarkably long, with most theories suggesting there should only have been about a 2 or 3 day delay. Now, accretion disks are usually made out of hydrogen, but this particular object had an accretion disk comprising at least 50% helium. Goodwin believes the excess of helium may have slowed down the heating process on the disk. That's because helium burns at a higher temperature and therefore may have caused the powering up process to take longer.
We saw what's called an accreting pulsar powering up coming into outburst with more than 7 telescopes over the period of about 2 weeks. So this kind of object is a neutron star that's in a binary orbit. So if you don't know anything about a neutron star, it's a dense remnant of basically a dead star. And they're so dense that they are about the size of Melbourne, but they hold about 1.5 times the mass of our sun. So they're very dense objects and have really strong gravitational fields. And this means that when they're in a binary orbit, because they have such a strong gravitational field, they can pull material from the companion star or the star they're in an orbit with, and this material will form a disk around the neutron star. This is actually one of the only ways that we can see neutron stars because they don't themselves emit any light or anything. So when they're in these what's called accreting systems, it's one of the only ways that we see the behavior of material in these strong gravitational fields around neutron stars. So they're really interesting to study for that reason. And we actually saw a neutron star powering up into an accretion outburst. So an accretion outburst is when the material in the disk has reached a critical mass, and the material in the disk will start piling onto the neutron star itself, and this releases extraordinary amounts of energy, so about 10 times more energy than the sun releases in 10 years every second. And so these are so energetic that they emit light across the whole electromagnetic spectrum, but particularly in X-rays, because X-rays are a very energetic form of light. And so we actually saw from the beginnings of this accretion outburst, when there was just optical light, so kind of lower energy emission, and then it started ramping up over the next 12 days, and we started seeing UV light, and then we eventually got an X-ray detection. And these are the first detailed observations of an accretion outburst with this many telescopes, because usually we don't know these outbursts are going to happen. They can happen at any time, and they're not very common as well, so they're quite rare to catch. And so there aren't actually very many observations or any detailed observations of this ramp up to this accretion process and the accretion process itself.
And so when you looked at this, could you tell exactly when the material that was accreting onto the neutron star heated up sufficiently to burn in X-rays? Was this in the form of a sudden explosion, or was it doing it as it was falling on the neutron star? Or are we thinking more like an extreme nova event where it's actually piling up on the surface of the neutron star?
Well, so interestingly, in these accreting neutron star systems, we actually see 2 types of emission during outbursts. So we see this kind of, I say lower energy, but it's still extremely high energy accretion emission, which is from this kind of slow piling up of material onto the surface of the neutron star. And then once that material has piled up after a bit of time, we see these things called X-ray bursts. And X-ray bursts are huge explosions on the surface of the neutron star itself that consume all of that accreted fuel. So we actually we saw the ramping up of the beginning of the accretion onto the neutron star, which is when we got the first X-ray detection. And then a little bit after that, we got an X-ray burst, which is a huge explosion.
So this is actually on the surface of the star itself.
Yes.
Does this tell us anything about what the surface of a neutron star is?
Yeah, so there's a lot of researchers that do study this because we don't really understand how matter behaves at those densities that are reached inside of a neutron star.
Yeah.
It's kind of a bit of a mystery to scientists at the moment because it's just so dense. And so by studying this emission that we can see and how bright the X-ray bursts are, how long they go for, as well as from the accretion emission, we can actually, if it's a pulsar, which the one we were looking at was a pulsar, the X-ray emission we see will be what's called pulsed, and we can measure the spin period of the neutron star, and that in itself can tell us something about the equation of state or how the matter is behaving inside of the neutron star, because it could tell us how fast it's spinning and something about the mass and radius and surface gravity of the neutron star. So yeah, it does give us some information or insight into the physics of these objects and at really high densities.
It's a fascinating topic, isn't it? Because we don't actually know where above the surface of a neutron star the pulse originates from in a pulsar.
Yes, we don't. It's the whole idea of a neutron star atmosphere as well is something that we again don't fully understand. And interestingly, in these accreting neutron star systems, they have really strong magnetic fields, and the magnetic field can actually have an effect on how material is pulled onto the neutron star's surface. So it can actually channel the flow of the accreted material, and it can cause it to perhaps be accreted onto the hotspots, so onto the magnetic poles, so at a certain location on the surface of the neutron star. And it can also affect the disk of material around the neutron star. So the magnetic field can truncate the disk, so it means the disk won't extend all the way down to the neutron star surface. It will be stuck a little bit away from the surface, and this is kind of due to the atmosphere of the neutron star and the effect of its magnetic field and what's happening around it. So by looking at observations of these systems, we can learn some information about what happens around the neutron star as well as the neutron star itself. But there's still lots we don't know.
What do we know about the binary companion?
Well, the companion in this system is actually very interesting. It is only 5% the mass of our sun, which makes it a little bit larger than Jupiter. So it's basically a planet. It's very, very small.
This was a red dwarf?
They call it a brown dwarf, but
it was a brown dwarf.
In a different study, they call it a brown dwarf, but I'm not convinced it is a brown dwarf. So there have been some evolutionary studies of this system to look at what it looked like maybe a few billion years ago when it first started the whole accretion and stuff like that. And they actually find, I've actually done one of these studies, so I found that the companion star used to be much bigger. So it used to be about the same size as our sun. And it's been stripped over the past 3 billion years down to something that is only about 5% the size of our sun.
Oh, that's
and so that kind of says something. Yeah, so it's really been eaten by this neutron star. And actually, that is why the reason that we think that this companion star used to be much more massive is because of its composition. So it's like 50% helium, and a star that is smaller than our sun doesn't reach 50% helium in its core within the age of the universe, because the way that how long it takes to go through the process of hydrogen burning and then begin burning helium in the core, it is just not possible for a small star to get to that point. So that means that this star used to be much bigger, and over the course of the evolution, it's been consumed by this pulsar and releasing all of these energetic outbursts.
What can you tell about this? I guess it may once have been a G-class star, and if it's lost its outer layers like that, what does that say about its internal structure now?
Yeah, so I'm not even sure we could even call it a star anymore, because it's probably not even doing any nuclear burning at all, and it's likely fully convective. And the reason for this is because not only has it been consumed by this pulsar, like all of its mass has been pulled away, it's also been heavily irradiated by these energetic outbursts. So all of these huge explosions and light being emitted during these outbursts that we're seeing actually have an effect on the donor star because it's irradiating it, and that can affect the internal structure of that star. So it's really had a hard time, this star.
But it's still got enough mass there to instigate some type of fusion, core fusion, obviously, or not.
Well, it could perhaps be, or it could just be not really doing much nuclear burning at all and just sitting there, because we actually don't see this companion star in optical.
Oh, wow.
It's too faint for us to observe with any of our telescopes. Yeah, so we barely see this system at all when the accretion outbursts aren't happening, and then it becomes bright and we see it for about a month, and then it goes quiet again for another 4 years, and we barely see it. All we see is a very low level accretion luminosity, which is the disk basically filling from the companion star. But yeah, we don't really see the companion.
Wow.
It's very small.
Not even the core of the companion is shining brightly, bright blue or anything like that? Nothing?
Nope.
Oh, wow. See, when you were first talking about this companion, I thought, oh, well, this is a red dwarf star. And then you said, oh, no, we think it's less mass than that. Oh, well, it's a brown dwarf, but a lot of brown dwarfs sort of start their lives as red dwarfs, and then they lose a little bit of mass and then become brown dwarfs. But this is mind-blowing. This is so different.
No, this used to be... it used to be a much more massive star.
Have you done a paper on this yet, on the companion yet?
Yeah, so I published a paper actually about 3 months ago, also in Monthly Notices of the Royal Astronomical Society. It's on archive as well, where we modelled the binary evolution. So we looked at how the companion, what it originally looked like, and how it evolved over the 3 billion years that we think this system has been evolving for. And we ended up with a system that looks like the one that we see today.
That's Adele Goodwin from Melbourne's Monash University. And this is SpaceTime. I'm Stuart Gary. Still to come, the solar system's largest impact crater discovered on the Jovian moon Ganymede. And the International Space Station's about to get a little bit smaller with the deliberate destruction of one of its modules. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Astronomers have discovered what appears to be the solar system's largest impact crater on the Jovian moon Ganymede. If confirmed, it would displace the 2,500-kilometre-wide South Pole Aiken crater on Earth's moon, which currently holds the record as the solar system's largest impact crater. The new findings, reported in the journal Icarus, are based on a new detailed analysis of image data from NASA's Voyagers 1 and 2 spacecraft, which visited Ganymede in 1979 and 1980 respectively, as well as more recent images taken from NASA's Galileo mission, which explored the Jovian system between 1995 and 2003. The authors wanted to investigate the orientation and distribution of ancient tectonic troughs and furrows found on Ganymede. Surprisingly, they discovered that these troughs are actually concentrically distributed across most of the entire surface of Ganymede, and this global distribution suggests they're actually part of a single giant crater covering much of the Jovian moon. The authors say the radial extent of the multi-ring measured along the frozen moon's surface is some 7,800 kilometres. Ganymede's surface is categorised into two primary areas, simply known as dark terrain and bright terrain. The dark terrain is extremely old, with many craters as well as the trough formations. On the other hand, the bright terrain is comparatively recent, with hardly any craters. These two types of terrain are not coherently arranged and are randomly distributed over Ganymede's surface. The furrows are believed to be Ganymede's oldest geological features because they're only found on the dark terrain. And there are many impact craters which were superimposed on top of them later on. The study reanalysed the distribution of these furrow formations over Ganymede's entire surface, revealing for the first time that almost all of the furrows were concentrically aligned around a single point. The study showed that these furrows did indeed form giant concentric rings over the entire moon. From this, the authors surmised that there's a giant multi-ring impact crater which covered the entire surface of Ganymede before the formation of the bright terrain areas. A similar ring structure, known as the Valhalla crater, remains on the surface of Callisto, another Jovian moon. Until now, the Valhalla crater has been the largest identified multi-ring crater in the Jovian system, with a radius of approximately 1,900 kilometres. Based on the results of computer simulations, the study's authors from Kobe University as well as Japan's National Institute of Technology speculate that Ganymede's giant crater could have resulted from the impact of a 150-kilometre wide asteroid into Ganymede's surface at a speed of around 20 kilometres per second. They estimate that the impact occurred around 40 million years ago. The European Space Agency's Jupiter Icy Moon Explorer mission JUICE, which is slated to launch in 2022 and arrive in the Jovian system in 2029, will increase science's knowledge of Jupiter's many moons, including the 5,263-kilometre wide Ganymede, which is the largest moon in the solar system and bigger than either the planet Mercury or the dwarf planet Pluto. Discovery that the aftermath of such a large-scale impact remains on Ganymede's surface is greatly significant in terms of the moon's formation process and evolution. For example, Callisto is almost the same size as Ganymede. However, it's not thought to have an internal structure composed of differentiated layers. On the other hand, Ganymede is thought to be composed of a differentiated layered structure consisting of rock, iron and ice. An enormous amount of heat would be needed to form these differentiated layers. And it's possible that the aforementioned large impact could well have been the source of this heat. The discovery will also have substantial significance for the Ganymede exploration programs scheduled for the coming decades. The image data from both the Voyager and Galileo missions only provide partial views of the satellite's surface. It's hoped that future missions like JUICE will be able to confirm and test the study's results by conducting detailed investigations into the multi-ring formations and whether or not there are any other remains of large-scale impacts. Hopefully, this will result in a deeper understanding of the origins and evolution of Ganymede, as well as Jupiter's other moons. This is SpaceTime. Still to come, SpaceX completes a test hop of what will eventually become its colonial transport starship, and the International Space Station's about to get a little bit smaller with the deliberate destruction of one of its modules. All that and more still to come on SpaceTime. A basic test article prototype of SpaceX's future interplanetary colonial transport system Starship has successfully completed a test hop at the company's Boca Chica test center on the Texas Gulf of Mexico coast. The successful test hop, which lasted less than a minute, used the SN5 prototype, little more than a large metallic cylinder built in just a few weeks. SpaceX boss Elon Musk, who sees his Starship as a colonial transport system to colonize Mars, tweeted that Mars was looking real following the flight. The estimated 150-metre test hop flight went straight up and descended straight back down again, landing in a cloud of dust and demonstrating good trajectory control. Last year, a smaller test article called Starhopper also flew to an altitude of around 150 metres before landing safely. But since then, several larger test articles have exploded during ground tests as the learning process of trial and error continues. Originally called the BFR or Big Falcon rocket, at least that's what Musk says it stood for, Starship is the culmination of Elon Musk's dream to develop a fully reusable super heavy lift spacecraft capable of carrying 150 tons of people and cargo to orbit and 100 tons on missions to the Moon, to Mars and interplanetary journeys across the solar system. Technically, Starship will be the upper stage of what would be a two-stage launch system. The 230-ton first stage, called the Super Heavy, would be 68 metres long, 9 metres in diameter, and constructed out of stainless steel. It would be powered by 37 liquid methane and oxygen-propelled Raptor rocket engines, providing some 72 meganewtons or 16 million pounds of thrust. The 120-ton upper or Starship stage would be 50 metres long, also 9 metres wide, and powered by 6 liquid methane and oxygen-fueled Raptor rocket engines, 3 designed for atmospheric flight and 3 for vacuum. They'd deliver approximately 12,000 kilonewtons or 2,600,000 pounds of thrust. The Starship's also equipped with its own retractable landing gear, allowing rocket-assisted vertical landings. Refueling tankers and satellite payload delivery upper stage versions would also be produced. SpaceX plans on using the Starship Super Heavy launch system to replace the company's existing Falcon 9 and Falcon Heavy launch systems, as well as its Dragon capsules, during the early 2020s. We'll keep you informed. This is SpaceTime. Still to come, the International Space Station's about to get a little bit smaller, with the decision to deliberately destroy one of its modules. And later in the science report, Russian President Vladimir Putin approves the world's first coronavirus vaccine, even though it hasn't gone through proper testing. All that and more still to come on SpaceTime. A Russian Progress cargo ship, which will ultimately detach and destroy one of the modules of the International Space Station, has successfully docked with the orbiting outpost just 3 hours after launching from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The fast rendezvous flight aboard a Soyuz 21A rocket allowed the spacecraft to berth with the space station's Pirs docking port after just 2 orbits.
There goes the second umbilical. The engine start sequence has been initiated. We have engine start, turbo pumps now coming up to flight speed, now at maximum thrust, now ignition, and liftoff. Liftoff of the 76th Progress resupply craft heading for the express lane to the International Space Station. Good roll, pitch, and yaw program are in. Progress heading out to the northeast in an orbit inclined 51.6 degrees to catch up to the International Space Station. The station now passing directly over the Baikonur Cosmodrome. All vehicle parameters reported to be stable from the blockhouse in Baikonur. Good pressure reported in the engine chambers. Yaw, pitch, and roll, all nominal, according to the launch conductor at Baikonur. Liftoff occurred right on time at 9:26:22 a.m. Central Time, 7:26:22 p.m. in Baikonur. We're about 10 seconds away from booster shutdown and first stage separation. And there are the boosters now separated. Structural parameters continue to be normal. The Soyuz now being thrust towards its preliminary orbit for the Progress resupply craft on the power of the second stage engines. 2 minutes, 50 seconds into the flight. Everything proceeding in great fashion so far. No issues reported from the blockhouse in Baikonur. The vehicle reported to be stable. And there is the jettisoning of the launch shroud, the Soyuz 2.1A booster. The next milestone will be second stage shutdown at the 4-minute, 37-second mark. The second stage continues to burn in nominal fashion. We are standing by now for second stage shutdown and separation. And second stage shutdown is confirmed and separation, and the third stage is up and running. The Progress resupply ship now heading towards its preliminary orbit on the singular power of the third stage engine. The International Space Station is now in front of the Progress. At the time of third stage shutdown and spacecraft separation, the station and its 5 residents will be about 1,100 miles ahead of Progress. The vehicle reported to be rock steady and stable as it continues its climb uphill at the 7.5-minute mark into the flight. The reports from the blockhouse in Baikonur continue to be good. Good structural stability, good orbital parameters so far. Having passed the 8-minute mark into the flight, the Soyuz booster traveling almost 15,000 miles an hour, 125 miles in altitude, 860 miles downrange from the Baikonur Cosmodrome. Just a few seconds away from third stage shutdown and spacecraft separation. Third stage shutdown confirmed and spacecraft separation confirmed. Right on time. Now standing by for solar array deployment. Navigational antennas now deployed. All appendages, as they are called, have been deployed. The solar arrays, the navigational antennas, the external television camera. So the Progress is now in its preliminary orbit, having completed a flawless climb to orbit following an on-time launch from Site 31 at the Baikonur Cosmodrome in Kazakhstan. The Russian Mission Control Center in Korolyov, outside of Moscow. Those flight controllers now in control of the journey of the Progress to the International Space Station. This is a quick 2-orbit rendezvous. The Progress atop the Soyuz 2.1A booster launched into a narrow 15-degree corridor, a very tight corridor to accommodate a precise pinpoint path to its preliminary orbit to place the Progress on a precise course to the International Space Station. A series series of engine firings now will follow over the course of the next couple of hours to raise the altitude of the resupply craft and to fine-tune its path as we move toward the vicinity of the International Space Station.
Progress MS-15 was carrying 2.7 tons of fuel, water, food, medicine and other supplies for the Expedition 63 crew aboard the orbiting outpost. The mission also carried special detector equipment to try and trace the source of elevated benzene levels detected in the space station's atmosphere. The levels aren't a problem yet, but it'd be nice to know where they're coming from. The Progress will remain docked at the space station until December. However, when it comes time to leave, the Progress MS-15 won't undertake the usual undocking and departure. Instead, it'll carry its Pirs docking port away with it, acting as a tug to pull the module safely away from the space station's nadir bottom port on the Zvezda module. It'll then drag the Pirs down into Earth's atmosphere, where it should all burn up over the eastern South Pacific Ocean. The 3,580-kilogram, 4.9-metre-long Pirs docking port is being removed to make room for Russia's long-awaited Nuka science laboratory, which will be berthed to the port currently used by Pirs. Nuka has its own docking port, which can replace Pirs for future Progress and Soyuz missions. The Pirs was launched way back on the 14th of September 2001, and it's provided the space station with a docking port for Soyuz and Progress spacecraft, as well as an airlock for spacewalks by cosmonauts using Russian Orlan spacesuits. Pirs was also capable of transferring fuel from docked spacecraft to the space station's Zvezda and Zarya modules, or the other way, from the space station to docked spacecraft. The Pirs design was based on the former Soviet Union Mir space station docking module and was initially only meant to last about 5 years. But ongoing delays with the development of Nuka has kept the Pirs operational for 4 times its original design life. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with a science report. Russian President Vladimir Putin has thrown caution to the wind, announcing that his country has approved the first coronavirus vaccine without undergoing the usual Phase 3 human trials, usually a vital step in proving a drug is safe and effective. Professor Danny Altman from Imperial College London says Putin's actions are a massive red flag for immunology specialists. The Phase 3 trials are usually the final stage of drug testing and involve tens of thousands of participants. At this stage, there is no peer-reviewed evidence supporting the new vaccine, which has been named Sputnik V. Now, although Putin's not taken the vaccine himself, the drug has been administered to his daughter. Russian officials say at least 20 countries have already asked for more than 1 billion doses of the vaccine, and several American companies are also expressing keen interest. Large-scale production slated to begin in September, with some 500 million doses to be produced every year in 5 countries. A new study has found evidence that one Chinese government research institute is responsible for well over 400 fake scientific papers. A report in the journal Science claims Elizabeth Big, a microbiologist turned research integrity expert, together with a team of forensic detectives, believe it's one of possibly dozens, if not hundreds, of so-called Chinese paper mills producing tens of thousands of fake scientific papers by copying research from legitimate scientists and making ever so slight changes to their work in order to make the research outwardly appear original and different. The plagiarized work is then submitted for publication in reputable scientific journals around the world. The Norwegian investigators who uncovered the scam believe they've found only a small fraction of an industry set up in China and engaged in the comprehensive, systematic falsification of research material on a massive scale. The investigators' first big clue was the appearance of the same images turning up in a range of different research papers. The detective work uncovered multiple examples of the same images being duplicated, reversed, inverted, cropped and enlarged, and then republished in completely different papers. Scientists have confirmed that most of the hulking sandstone boulders known as sarsens, which make up Stonehenge, come from a site just 25 kilometres away on the edge of the Marlborough Downs. The origins of the stones used to build Stonehenge some 4,500 years ago, and how they reached their Neolithic resting place have been the subject of intense debate among archaeologists and geologists for over 400 years. Two main types of stones are present at the monument: the sarsen stones, which form the primary architecture of Stonehenge, and the blue stones near the centre of the monument. The smaller blue stones were traced to Wales years ago, but the larger sarsens have remained a mystery until now. Scientists use portable X-ray fluorescent spectrometry to determine their chemical composition and then compare them to possible extraction sites. The new findings, reported in the journal Science Advances, will help explain how the monument was constructed and perhaps offer insights into how these 20 to 30-ton monoliths were transported. Scientists have found evidence that Torres Strait Islanders were cultivating bananas more than 2,000 years ago, and that they were intensively farming bananas at least 1,300 years ago. A report in the journal Nature, Ecology and Evolution claims archaeologists uncovered banana microfossils, stone gardening tools, charcoal and a series of retaining walls dating back some 2,145 years to a site on Marbayang Island in the Torres Strait between Australia and Papua New Guinea. Bananas, technically a berry, are native to tropical Australia and Indo-Malaya. The Cavendish cultivar, the most common in the world, is now grown in 135 countries. Well, just when you thought 2020 couldn't get any stranger, comes news of a biodynamic wine. Making it requires the most advanced pseudoscientific techniques, with trained scientists adjusting for opposing vortices, the movement of the planets, and the natural energy found in butterfly venom. Still, despite all the magical hocus-pocus, there are those out there who say that biodynamic wines really do taste better. But Tim Mendham from Australian Skeptics says that sounds like it's time for another double-blind test.
Biodynamics is an offshoot, a variation of organic farming and wine in particular, but biodynamic involves some very, very strange practices, some very, very spiritual-based practices like using the astrological signs, etc., to decide when you plant something. Some of the really weird beliefs highlighted in this particular blog, which is called Vinography, if someone wants to look it up. You can make a mould of a woman's stomach when she's pregnant to energize tea preparations. That's, obviously the classic example is putting manure in a cow's horn and planting that with the vines to actually encourage special growth. There's the preparations involving stuffing deer bladders with particular flowers and hanging it above head height in an alder tree for the summer. It's crazy stuff, quite frankly. I mean, and yet some people are saying that biodynamic wines, the wines that are grown and processed under this regimen, actually taste nice.
Is there any scientific evidence to verify any of this?
No. Bluntly, no.
Okay, let's move on to the next topic then.
Around the world, there's about 700 vineyards that are using it. I don't know how many vineyards there are around the world, but I mean, like you would look it up probably. But that's a decent number. Some of them, a lot of them are little brands, that just might be purely biodynamic. Some of them might have a mixture of things they're using, organic and biodynamic, or even just traditional organic and biodynamic, and growing them separately. Obviously, organic you can't grow with non-organic because everyone gets very upset.
You couldn't grow it with biodynamic either, because again, you're modifying the environment, aren't you?
Yes. If you're adding cow manure in a horn, or deer bladder, you might not go down too well. Yeah.
Deer wouldn't be too happy about it either.
No. But people have said they've tasted it. Occasionally they do sort of double-blind tests to say which wine tastes better, and one particular test said basically the biodynamics came out almost entirely on top always. But the problem is finding two wines that are exactly the same sort of wine, exactly the same location that they're grown in. And of course that's a major issue with wine, is the soil and the sunlight and the slope of the land that you're on and all sorts of things. So, trying to find two wines that are exactly the same and to test whether a biodynamically grown one is better than a non-biodynamically grown one is very difficult, but it's a thing you have to do, really. You want to do enough of them to see if there's any difference. Some have said there's none. Some have said if you know it, you might tend towards a biodynamic because it seems so natural, even if it is a bit weird.
The obvious question, is it for the same price as a regular wine?
I don't know. I haven't gone out and bought any. I don't know how easy it is to buy. I presume it is. If there's 700 vineyards around the world, there must be some available.
I'll bet you a block of flats in Tasmania that this is going to cost a lot more than a regular bottle of wine.
Well, I think sort of organic often does. You don't get really cheap organic wines. So, yeah, you don't get your $5 bottle of plonk. I drink a lot of wine. So.
You seem very knowledgeable on it, yes. All right, now
I've unscrewed a lot of bottles.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.